This video, I believe, is example number 5 of different types of probability problems that we're trying to solve. And we want to bring to your attention that with a lot of the probability videos, we draw upon some of the methods and results that we had from previous videos that we posted dealing with the different types of permutation problems that we solved, and there was a whole series of videos of different types of combination problems that we solved. And if you go to the website at digito-university.org and click on the combinatorics and probabilities section, you'll find the earlier videos there. So if you're watching our probability videos and we're referring to results that we obtained in the earlier videos and those results are not familiar to you, go to the website and you can access those earlier videos then. Okay, in this video we want to consider another problem really that is solvable using combinations. And the problem states a box contains 20 transistors, 5 of them are defective, and if 3 transistors are removed from the box at random, what is the probability that at least one of those selected transistors will be defective? So let's see how we have this. We have 20 transistors total inside of the box. And then out of these 20 transistors, 5 of them, we have 5 defective transistors, meaning of course that we have 15 non-defective transistors. Now we're selecting 3 of them. So when 3 of them are selected at random, perhaps all 3 of them will be defective. Or perhaps 2 out of the 3 of them will be defective. Or perhaps out of the 3 transistors that we select, maybe only 1 of them will be defective. Or out of the 3 transistors that we randomly choose, perhaps none of them will be defective. We don't need any plus signs in yet. These are just simply the different possibilities. Now, if we consider, well, what would be the probability of this event, plus the probability of this event, plus the probability of this event, plus the probability of this event, these are all the possible ways that we could select the 3 transistors. So the probability of all of these has to add up to 1. Now, notice here, let's bring this over to this side of the equation. So we have 1 minus the probability that when we select 3 transistors, none of them are defective. That is equal to the probability that at least one of them is defective, plus, or that one of them is defective, plus the probability that 2 of them are defective, plus the probability that 3 of them are defective. So let's be clear. We have the box of 20 transistors. We know that 5 out of the 20, or 1/4 of them, are defective. 3/4 of them are not. So out of the 20 transistors, we randomly choose 2 of them. When we do that, maybe 1 of those transistors is defective, maybe 2 of those are defective, or perhaps all 3 of them are defective, or the 3 transistors that I choose at random, maybe none of them will be defective. Well, this right here, collectively, this aggregate sum right here, that is the probability of selecting at least one defective transistor. And remember what the problem was. We select 3 transistors. What is the probability that at least one of them is defective? Well, if we can figure out what would be the probability of choosing 0 defective transistors and subtract that from 1, that would be equal to this aggregate sum here of having 1 defective transistor, 2 defective transistors, 3 defective transistors. So together that would be the probability of selecting at least 1 defective transistor. So how can we figure this out? All right, so what we need to do then is well, let's make some room. The probability of selecting zero transistors, that would be equal to the number of ways that we can select the 0 defective transistors the number of ways to select 3 non-defective transistors divided by the total number of ways, to select 3 transistors. Now let's make sure that this makes sense to everybody. Here we have our box of 20 transistors. Five of them are defective transistors. 15 of them are non-defective transistors. We're randomly going to choose 3 of them. So what is the number of ways that when we select 3 transistors out of this group that none of them are defective? Well, that's the same thing as asking, here we have 15 non-defective transistors. How many ways can we choose 3 of them? Obviously, the order in which we choose them doesn't matter. So the number of ways that we can select 3 non-defective transistors is, back to our combination. That's the number of ways to select 3 non-defective transistors. Now we have to consider, as if we want to know the probability of that, we have to divide that by the total number of ways that 3 transistors could be selected. And that, of course, is there's 20 of them altogether. Out of the 20, how many ways can we choose 3 of them? The order in which we choose them doesn't matter. So again, of course, it's a combination problem. So this ratio right here is the probability of selecting 3 transistors and none of them are defective. So this is equal to so all we have to do now is figure out what these binomial coefficients are. So here we have the binomial coefficient 15 over 3 in the numerator And down here in the denominator, we have 20 over 3, this binomial coefficient. So let's see. Before we do our simple calculation, let's make sure that this makes sense to everybody now. This is the total number of ways that when we choose 3 transistors, none of them will be defective. This is the total number of ways of choosing 3 transistors, period. So this ratio here will give us the probability of selecting 3 transistors, none of them being defective. Okay, and this is 15 factorial divided by 3 factorial times 12 factorial. And this will be divided by, here we have 20 factorial over 3 factorial times 17 factorial. These cancel out, and let's make some room. Here we have 15 factorial over 12 factorial. So we have 15 times 14 times 13 times 12 factorial. That is 15 factorial. Now we divide it by 12 factorial. Then we'll multiply this expression by 17 factorial over 20 factorial. So we have times 17 factorial, inverse and multiply, divided by 20 factorial. And that's 20 times 19 times 18 times 17 factorial. That's 20 factorial. So this cancels. These cancel. And we have 15 times 14 times 13 divided by 20 times 19 times 18. So let's see what we have. 5 would go into here 3 times. 5 would go into there 4 times. What else do we have? 2 can go into here 7 times, and this would be 9 times here. So in the numerator we have 3 times 7 times 13. Again, let's make some room. Three times 7 times 13, and down in the denominator we have 4 times 19 times 9. And here 3, that'll make this a 3. So here we have 7 times 13, that'd be 91. And down here we have 19 times 12. That'd be 18, 3, 9, 1, 8, 12, 91 over 228. So this right here, that's our probability of when we select 3 transistors of having 0 transistors, 0 defective transistors. Now, from up here, we had that 1 minus this is equal to the probability of having 1 defective transistor plus the probability of having 2 defective transistors plus the probability of having 3 defective transistors. Collectively, we could say that would be the probability of selecting at least one defective transistor. So this is 1991 over 228. So we have 1 minus 91 over 228. So we do that subtraction, and let's see, we have 228 over 228 minus 91 over 228, and that's 137. So this 137 over 228, that is the sum of these individual probabilities right here. And we could say then that would be the probability of selecting at least one defective transistor. Okay, now if you're not completely comfortable with this solution, what we can do is we determine what this was. That was 91 over 228. What we can do is, this is 91 over 228. We can also determine what this one is. We can determine what this one is. And we can determine what this one is by using combinations, the same way as we did before. So what we can do is we can determine each one of these, and we can then, once we do that, add them all up and see, do we indeed obtain 137 over 228. And I don't think we have time to do that in this video, so come back, join us in the second part of the video, and what we'll do is we'll calculate what these are using combinations and add them up and see, do we indeed obtain 137 over 228. So come back, join us for the second part of the video, and we'll finish off the rest of the problem.